This video is a militia engineer task, and it is inspecting a landmine for use. I've been doing a lot of videos in the historic ordnance series on different types of landmines around the world. And the very first thing that you do before you emplace any mine is you inspect and you inventory that mine. Make sure you got all the parts that you need to use that mine. You have the correct arming wrenches or arming keys depending on the mine. And you need to inspect the mine to make sure it's usable, especially if it's an older mine. A lot of anti-tank mines appear to have been made back in the 50s and 1960s, and then those are still in inventory today. Depending on what the filler is, that makes it dangerous, especially if it's a TNT based mine. So I'm going to give you some things to look for when inspecting mines. I'm going to pull out different types of training aids that I have, and I'm going to mention certain things for it that you should look for in whatever mines you may come across that you get either from supply from an outside source or capture from an enemy. Now, first off, we'll start with a basic metallic anti-tank mine. This particular one is a training aid for an American M15. So the first thing that you're going to do when you get one of these mines, you're going to inspect it to make sure that there isn't a ton of corrosion on it. A small amount, not an issue. But if you come across corrosion on one of these mines, you want to check it and see how bad it is. Is it just surface like this? Or is it bubbled up? You know, there's chunks coming off. If there's chunks coming off, pick at it a little bit. See if it goes all the way through. See if the case has been breached. There are some types of explosive compounds that when it gets wet, it becomes useless. So you want to make sure water is not getting inside the mines. Another thing you're going to check is the seam, where the top half of the mine and bottom half is joined together. Make sure that that is solid going all the way around the mine. It's not coming apart. You also want to check the bottom of your mine. You're checking for rust. You're checking for damage. When you're going through, you're looking at the entire mine. If there's dents, as long as the dent is not in a location where it will interfere with the operation of the mine, doesn't matter. But if we get a dent, say up near a pressure plate, which could potentially lock it in place, that would be damage that would prevent that mine from being used. You also want to go through on all anti-tank mines if they have a secondary fuse well, and you potentially will be emplacing some with an anti-handling device. You want to go through and check inside that fuse well. Make sure there's no debris in there. If there is, get it out one way or another. But be gentle. Don't start pounding away at it. If you need to take a little piece of wire or something in there to pull that object out, so be it. Another thing that you definitely want to do with anti-tank mines, you want to check the fuse wells. Make sure there is no debris or anything in the fuse well that would interfere with operation. If there is, you need to get it out. And with the fuse well, the easiest thing is set it on the side, tap it to dislodge. Now, depending on the mine, you could have, like on the M15, the fuse plug here, you have moving parts. You need to check the operation. If it's in the safe position on the M15, the bar should be to the outside. But you need to check that when you flip it over to the armed position, that bar moved into the correct location easily. It did not bind, it did not get stuck. And then make sure you can return it back to the safe position. Now if it's a clockwork type fuse, like with the Russian TM62 mic, the MVCH 62 fuse, you're not going to go through on that. Press the arming button to make sure that the fuse is arming. Basically with that one, when you put it into operation, you hit that arming button, you hear the clockwork going, you know at that point the fuse is working properly. Now with low metallic mines, how about, as an example for this, Russian TM62 P3 low metallic anti-tank mine, a plastic case mine. With this type of mine, what you're going to do with all plastic case mines or all non-metallics, you need to pay particular attention to the casing. You need to make sure that there isn't chunks broken off. You need to make sure that there isn't cracks that allows water or moisture to get inside. And if it does get inside, you need to know what the explosive filler is. Water will have less of a effect against a Comp B filled landmine than it will a TNT filled landmine. Once again, depending on the manufacturer of the explosive that's in there, that little bit of moisture could potentially neutralize that explosive effect, or at least diminish it, as not all of the explosive will detonate when you want it to. So make sure to know what your mine has if it's plastic case, and if a little bit of damage will be that much of an issue. But an issue with plastic case mines is over winter, the plastic gets brittle, even if it's just in storage, and you have to watch for that. If that case is starting to spider web, it might be ready to fall apart. If there's already chunks falling off of it because it got so brittle from the cold, well, maybe you want to use that mine for some other purposes than as an anti-tank mine. And if this mine has a TNT filler and it is greater than 20 years in age, I'll give you a date of that, greater than 20 years, you want to make sure you do not see anywhere on the mine from any location, a filler plug, a crack, anywhere. You want to make sure you do not see an oily or jelly substance coming out of the mine. If you do, that is pure nitroglycerin. Pure nitroglycerin is highly unstable, highly impact sensitive. You do not mess with it. That is one of the things they teach engineers when you go through basic demolitions. If you get anything, a case of TNT shows up, a case of dynamite, you see any type of oily or jelly-like substance coming out of that explosive, don't try to take it out. Don't handle it anymore. That needs to be destroyed immediately because the explosive compound is unstable. Now, some plastic mines may have a fuse that you need to check also. So we had the fuse plate on top of the M19 here. With this one, you would remove the shipping plug. You would look inside the fuse well. If it's in the safe position, you should see the firing pin off to the side. And then you would flip it over to armed. you'd flip it over to the armed position. You then look inside the detonator well, the fuse well, and you make sure at that point that the firing pin has lined up with where the detonator will be when it's in there. If it doesn't move, then that pressure plate, that fuse plate, 606 if I remember correctly, is not serviceable. And speaking of detonators, you could get some that are this small. All you have is the percussion cap here with a high explosive compound underneath on a plastic plug. You're going to want to check that. Make sure it's usable. Make sure nothing has impacted that primer. If it has and it hasn't gone off, you definitely don't want to use that detonator. You want to use a different one. If this thing is starting to fall apart, you wouldn't be able to screw it into the mine, or potentially you screw it in there and the primer falls off. You don't want to use that either. Now, what about anti-personnel mines? They have their own challenges. Let's start off with metallic ones. Bounding fragmentations are primarily metallic. Why? Because it's a fragmentation mine. So when you go through and you inspect these, you won't have the fuse on it. Just unscrewing the training aid here. You're going to go through, you're going to check the outside casing. And you're going to make sure water is not getting inside. So if you see rust on it, if it's just a little bit of surface rust, that's fine. But you get that scaly rust on there. Scrape it away, check, see, does the rust go all the way through into the mine? Why is that important on a bounding fragmentation? Because a bounding fragmentation has two charges. It has a propelling charge on the bottom, which is typically black powder. Black powder does not react well to water. And then it has the main charge, which could be a TNT, it could be a Comp B, an A6, whatever it is for that country. But when you're looking through checking the casing, the reason you're checking the casing is make sure water is not getting inside that could have compromised that propelling charge. If it did, this mine potentially is completely neutralized. Because a lot of bounding fragmentation mines, they do not detonate until they get a certain height away from the mine. Because connected to the base, there is a little piece of wire rope. It goes to a fuse on the bottom of the main part of the charge, and once it gets to the end of that tether, that little piece of wire rope, that's when it sets off the main fuse, setting off the primary charge, expelling the fragments. So setting off the fuse to set off the propelling charge won't necessarily detonate the mine if the propelling charge is too damp to be used. Now with the OZM3 here, and also with the OZM4, the Chi-Com Type 69 bounding fragmentation mine, you have another fuse well here where you put a blasting cap inside. You want to make sure that that fuse well is clear. There's no issues with it. If you're going to, with the OZM3, it was not continued with other series. If you're going to use it in command detonation, you're going to fire it electrically. You want to check out the wire leads. You want to make sure that the rubber has not degraded. It's not falling apart where you could cause a short, either setting the mine off in your face, or that short could prevent the current reaching it down inside to set it off. It may cross over before it gets to that point. And then you need to go through, check the fuses. Check the fuse body, make sure it's not crushed to the point where it's going to interfere with the striker that's running through it. You want to make sure that there's nothing inside here so that you can easily screw in the detonator if it's not already attached. The safety pins on top, you want to make sure they're going to move. You're just going to take the combat pin, as they call it, primarily in Russia. That combat pin, check it, see if you can move it a little bit. You don't want to pull it out. You just want to see, will it move in there when the tripwire gets snagged and pulls the pin out, or should pull the pin out. You don't want it binding in there. And you want to make sure that the actual safety pin can be removed when you're arming the mine. And then you also want to make sure, do a little test on it. Make sure that the fuse and the mine work together. An example on this, I was told this by a sergeant first class when I was a young engineer. He talked about his days back when he was a private. They had gotten in some cases of M16 bounding fragmentation mines. They got some M16s, they got some M16A2s. Essentially the same type of mine. However, they found out the hard way that the fuses could not be used back and forth. They were the exact same model of fuse, but they learned you couldn't take the ones that came in the crates with the M16s, use those on the M16A2s. The threads just didn't quite work. Even though it's the same model of thread, it was just that much different because of that manufacturing plant. They wouldn't go together. And they couldn't take those fuses that came with the M16A2s and use them on the M16s. So he said he had to stand there as a private and sort that giant box of fuses out so they could determine which fuse went with which series of mines. You want to catch those problems at your base before you even get to the location where you're going to prep your mines. Or if you're carrying them inside your pack on a patrol, because you're going to use it as part of your ambush or to cover your withdrawal. You want to know those problems before you get up there, and you have to put it in place, and then you find out, oh shit, I didn't do that, this mine is useless. Now, what about non-metallic, low metallic anti-personnel mines? What we have here is a Giata 64. It is an exact copy of a Soviet PMN-1 or PMN. Now with this, obviously you're going to go through, you're going to check the plastic body, but you got something here that you really got to pay a lot of attention to. The rubber. You want to make sure that any rubber component on an anti-personnel mine is not degrading. It's not gummy. It's not starting to crack. It's not dry rotting, because if that happens, moisture can get inside the mine, potentially neutralizing it. Now, it may not affect the explosive, may not affect the detonator, but it could affect those metal parts that are inside. Those springs, it could potentially rust away your firing pin. So you want to make sure any rubber on a mine, whether it is an anti-tank mine or an anti-personnel mine, it is not damaged, it is not degraded. And if it is, that mine cannot be used. Now, what about wooden cased mines? These are still out there. They're still out there because they were designed so that anyone could make them in a simple workshop. All you needed was the explosive and the fuses for them. Well, with these mines, you want to make sure that all the moving parts move the way they're supposed to. That it's not binding up because of moisture. That happens with wood. Wood sucks up the moisture out of the air, or maybe something's been dripping on it for a while because it wasn't stored properly. The wood will swell, and when it swells, you won't be able to pull it apart, and that mine also won't be able to function when you need it to. Example would be with the TMD Bravo. World War II design, an anti-tank mine, completely out of wood. When the wood gets wet, the pressure boards swell together, and when that happens, you take a mine that's supposed to detonate at 400 pounds of pressure, and you could push it up to at least 1,000 pounds of pressure required to snap those boards enough so that the mine can activate. So any wooden cased mines, you want to make sure the wood's not degrading, the wood hasn't been wet, it still operates the way it's supposed to. For any of the fuses that could be for these mines, and this is not a real fuse, you would go through, make sure the fuse is usable. Like with the bounding fragmentations, because a lot of the times it's the exact same fuse, you want to make sure it's not damaged to the point that the striker shaft in here is not going to move, or that the spring that's inside here is going to catch. It's not going to force the striker down to set off the primer, to set off the cap. And you also want to check your explosive block. Make sure it's not degrading. Make sure you don't see an oily or jelly substance coming from the explosive. Or with C4, I have had this, where it was stored improperly for so long that when we got it, the blocks themselves, even in summertime, essentially crumbled. The blocks had solidified, cracked in the packages. And then when we got it, we were trying to mold it to stuff because we were doing some breaching charges. We took the wrapper off. It literally fell to pieces. So we scraped those pieces together. We stuck them together with some C4 that was in better shape. Used that in a charge. And you know what we found after that charge went off? Those brittle chunks of C4 still sitting on the ground. They weren't even burning. So always make sure the explosive is not degrading. Depending on the type of explosive, each explosive has different things to watch for. With TNT, you're looking primarily for oily or gel-like substance coming from it. With plastic explosives or composition explosives, you're primarily making sure that it's still pliable as it's supposed to be. Directional mines. Claymores. What I have here is a training aid for an American M18A1. You're going to go through, you're going to make sure the plastic casing is not coming apart. If there's cracks in it, depending on the location, probably won't matter. Because these have, at least the American M18A1s, it has plastic explosive. It does not use TNT based explosives like you see with the Type 66 Chicom bounding directional mine or the Mon 50, which are TNT based. So if there's a crack in this, as long as it's not severe, you can still use it. But if you get a piece that's missing, especially off the front here, and you got the shrapnel inside is falling out, that mine probably shouldn't be used. Or if you got no choice, put some additional shrapnel to fill in what fell out. Put some tape over the front of it. tape it up, and then use it once. If you don't use it in that ambush, destroy it. You want to check the scissor legs, make sure that they move the way they're supposed to and that you can spread them apart. It's okay if they're a little stiff. It's if they're extremely stiff that you almost have to stand on it or pound on it to move it. That's probably not pretty good. You want to check the fuse wells, make sure there's nothing inside. If there is, you want to get that out of there. How are you going to get that out of there? Take it and just gently smack it to dislodge, going straight out, depending on the angle of the fuse well. The Yugoslavian Murad, the fuse well is straight up and down. Most other countries are angled, like the Claymore. You also want to make sure that the sights are not damaged. If the sights are damaged, you can't really sight it in correctly on the kill zone, can you? And if it is damaged, you're probably going to have to find some other use for that particular mine. And there's another component that you need to check very thoroughly. Firing wire. When you check the firing wire on a Claymore, you're going to check the plug. Make sure it's not damaged. Look inside, make sure it's not too corroded to be able to use. You'll find out when you do your continuity check. You also want to check over the wire. Make sure that the rubber insulation is not coming off. Make sure it's not so brittle to make it unused. If it is, you're going to have to come up with some other way to set that Claymore off. And you want to check the blasting cap. Make sure it's not damaged. This one is. This is just a trainer, doesn't matter. But you want to make sure that that blasting cap is in good condition. And I'm going to point this out because I have run into this more than once. Working with infantry, more than once, multiple units in different posts, I have been told that at Fort Benning, Georgia, at the infantry school, they tell the new infantrymen, don't touch the blasting cap. Don't touch it with your bare fingers because the oils from your fingers will deactivate the blasting cap. And that the only way they can hold the blasting cap is like this. Never, ever, ever touch the blasting cap, they're told. Well, I and my fellow engineers, when we hear that, we smack our foreheads and we remind them that, hey, we're the ones trained in this stuff, and we can tell you from experience, actually using it, you can touch a blasting cap. It's not going to damage it. And actually, it's a hell of a lot easier holding the blasting cap, inserting it into the fuse well, than it is holding a wire with it wobbling back and forth, and you're trying to line it up and smack it into that fuse well. It's actually a lot safer. Hold the fucking cap. I'm sure that's pissed off an infantryman or two because he's doing the same thing like those grunts did years ago. Well, they taught us at Fort Benning, never touch a blasting cap. Well, this combat engineer with a ton of experience, hands-on and training, is telling you, touch the blasting cap. Just don't get stupid with it. Learn the steps for the mines that you are handling. The particular model. The recommendations from the manufacturer. The instructions from the country that supplies them. Learn those steps, learn the specifics, learn the quirks for those mines, so that when you inspect them, you know when you come across a defect that could potentially make that mine non-mission capable. Now, for all my engineer brothers across the Patriot and militia movements, always remember, essay ons.